Welcome to this week's episode of Cloudbusting. Now, we're going to have a slightly different topic of conversation today. We're going to be talking about what we're calling the developer-led landscape and the sort of supply-demand imbalance between the requirement of developers and actually the availability of developers. And this actually comes up and lines up with one of the trends that we've got coming up. We've got our trends episodes that we're about to launch, and we actually have a trend around the talent crisis, as we like to call it. We'll be looking at that in a future episode. But today we're going to talk about it with Tyler Jewell. So Tyler is the managing director at Dell Tech Capital. Tyler, would you like to just say hi, introduce yourself, let us know a little bit about Dell Tech Capital?
Good morning. I'm glad to be here. Thank you for having me. I'm one of the MDs at Dell Tech Capital. Dell Tech Capital is the VC arm of Dell Technologies, which is the financial holding company of Michael Dell and Silver Lake that owns VMware, EMC, Dell, SecureWorks, and a bunch of other businesses. We are investors in enterprise technology, and we invest in things in and around the data center, including silicon, storage, networking, cybersecurity, developers, DevOps, edge, 5G, robotics, digital health, everything that technology can impact. We invest about $200 million a year as a VC. So that's a lot of Series A and Series B companies that we invest in. We have a pretty broad portfolio, about 130 companies, and of those, about 60 have exited and 8 IPOs. Many of them along the ecosystem and in the developer landscape that we'll talk a bit about today. And over the years, I've been a CEO 3 different times, and I've been an angel investor, and I've invested about $150 million across companies in the enterprise landscape.
Wow, excellent. Oh, looking forward to the conversation. So when you say you're investing Series A, Series B, what's your sort of minimum investment that you tend to go in for?
Yeah, what's nice about the way that we run our unit is that we don't really have any limits on how we invest or the check size that we invest in. But when you lead Series A and Series B companies, the first check is somewhere between $5 to $15 million in today's market. And sometimes we go earlier than that. We've done quite a few seed deals this year, which are smaller checks, and we've done some later stage things, which are even bigger checks as well.
Dave, when you come up with your new idea, I think you can chat to Tyler.
I'm writing notes as we speak.
Dave is with us. How are you, mate? You okay?
I'm okay, mate. Yeah, thanks. My ear infection, I think, is finally on its way out. And my wife is now nearly through COVID. So our isolation lasts for another couple of days in the house. It's a real pain because it's meant I've had an ear infection. I've had to do all of the sort of, to and froing to school with the kids and all that kind of stuff. On top of the day job. It's a bit rough, I tell you.
Yeah, I mean, you finally get to see what Tam actually does at home.
It's amazing. It's amazing how much weight she carries.
Oh, brilliant. So I thought before we get into the deep dive, just a little article I read yesterday, quite interesting about this. And again, it fits quite nicely with some of the trends coming out. And certainly one of the trends we're looking at is edge and edge computing and AI at the edge. And there was a really interesting article that was talking about Qualcomm, so one of the big chip manufacturers. And they're saying here, that the global cloud computing market this year worth about $250 billion. And I think we've discussed on previous pods that there's this 4 or 5 year forecast for it going up to $700-800 billion, massive compound annual growth rate. But this is particularly about Qualcomm and the chipsets that they're looking at really just implementing at the edge. And they've actually got a VP and general manager of Cloud Edge AI. Right? So they actually have that as a job title, which I thought was quite interesting anyway. And he was saying that he's calling this a next mega trend. He's saying, the next mega trend is underway. This is a guy called Mike Vildbill. He was saying that we've seen a lot of computation moving to the cloud, but you've got this yo-yo effect now where actually both data and the consumers of that data are actually happening at the edge. And he's saying, there's this poster child example of the autonomous car, right? So the fact that if the car sees that there's a pedestrian in the road, it needs to react, right? You don't have the luxury of time for that message to go back to the cloud, then come back to the car and then put the brakes on. It has to happen at the edge. And it's saying that the chipsets that Qualcomm are focusing on, they're really looking at speeding this up. And their latest set of chips, I really don't know much about this at all. They have this thing called inferences per second per watt. So this is how you measure the speed of it. And their latest chip does 240 inferences per second per watt, whereas their next competitor is NVIDIA, which is obviously another big manufacturer, who only have 60 inferences per second per watt. So it's 4 times fewer. So they are really looking at sort of getting into this space. And they saw an increase from last year. If you look at their last earnings, their IoT segment, which includes this, took in $5.1 billion in 2021, which was up 67% on last year. So it's a huge jump. And they're saying that this is really going to be a massive trend in our industry. And as you said, big mega trend coming up. Dave, thoughts on that? Tyler, thoughts on that?
Well, I think the conclusion is, very logical that it's getting costlier to move data across networks. I mean, even if the whole world was wired with fiber optics, it still takes 40 milliseconds for, data to get from one half of the planet to the other. And, elite gamers, for example, can have sensitivity all the way down to 6 milliseconds of reaction time, right? So if you're looking at, these large global networks of systems, you mentioned, autonomous cars. I'm thinking more about Metaverse, where if we're on a global Metaverse, the way that these games and these shared experiences really partition millions of users down to logical units of shared experience is they have to partition them regionally. And they have to be able to move the data and do the compute and computation within groups of people who are in the same co-location. And then for those who aren't, they have to have different algorithms for that. And so that's just going to be a huge driver for this edge compute, edge inference, and anything to keep the data, where it's sourced.
Yeah, indeed. I mean, I would say that it's going to be less a huge shift from cloud to edge, but just more a maturing of the edge and a maturing of the overall architecture. So we've seen, cloud providers introduce sort of fog type computing with the likes of Stack and Outposts, and that's useful for exactly the same sort of scenarios that Tyler was talking about. And the next natural thing is edge, both in terms of the power of the devices, as well as the sophistication of the architectures and the solutions for them, start to mature over the course of the next few years, that it's almost inevitable that we'll see an overall maturation of how solutions are created across the cloud and across the edge. I mean, I wonder if something like track and trace, for example, which is very, very large scale and a very ambitious sort of application of edge technology, is going to accelerate the use of edge and how that works. I don't know yet. I think it's maybe a bit too early to tell. And perhaps some of the patchy success of track and trace doesn't leave it with, the greatest of reputations. But yeah, I think inevitably architectural, we're heading in that direction.
We're definitely in a state where the world is looking for what that killer app is going to be that demands low latency. And so there's lots of examples of applications that can benefit from low latency, but until there is some globally consumer adopted application that only works if you get sub 10 millisecond latency, we're not going to get the fiber optic to the last mile. We're not going to have the deployment of the edge data centers that we need. We're also not going to get, the sort of high-end 5G that is necessary to do that until the consumers demand for that.
I think that's well said, Tyler. And so I think I would probably see what's happening now is almost, I don't know where we are on cloud 1.0, 2.0 these days, but the next big iteration of it will be this kind of, low-lying cloud and then edge cloud. But I think I agree it will be the huge investment that needs to come with the infrastructure to support that will be on the back of consumer demand. And I think the autonomous car thing is the example that everybody really uses. I don't know how many others there are yet.
There's a couple other examples that they used in the article. So one was actually, and also a little bit creepy, was monitoring workers to make sure they're wearing the correct PPE.
Oh yeah, that's edgy. That's edgy in the wrong way.
That's edgy in the wrong way, right? I thought, what's the sanctions of that? They're also talking about stock monitoring in shops, for instance. I mean, but again, it doesn't really.
No, you could do that with client server.
No latency issue there, right?
No.
And even the autonomous driving, I think that's a long ways off, and it's unclear that you need really edge compute as much as they claim you do for that. But the one that gets me is remote surgery. If somebody's going to cut into my chest and touch my heart from across the sea, I want that to be a pretty low latency event.
Yeah, you want that you want that to be a low latency experience for everyone.
Yeah, remote surgery. I'm all about that. Yeah.
Oh no, my internet's gone.
Yeah, it would be like your problems on getting onto the podcast yesterday, Jez. If you're trying to do an operation, that could have been fatal.
I'd have been a goner.
That is not a phrase you want to hear.
No.
So I think the thought is probably more evolution than revolution. From this.
I think so. I mean, it's in the interest, I guess, of a chip manufacturer to be touting the next wave of revolution. But I think the reality is this is a really well needed architectural evolution.
Yeah. So Tyler, we're going to be talking about the developer-led landscape, and you've got some interesting thoughts on this. You could maybe sort of help frame this, and then I'll let Dave dig into it a bit more.
Yeah, certainly. So early in my career, I spent a number of years in product roles at companies that were building developer tools or developer middleware. And I noticed this trend that the power and influence and impact and respect that developers had as a decision-making class was, fairly low in the ranks of the business professionals in and around the software industry. And starting about 12 years ago, I began building a database of companies who built products for developers, or were products built by developers for developers, or products that developers had a huge influence over, just to get a better understanding of the landscape. And one of the big things that I started to recognize, and this has been talked about in different forums, is that over the past 25 years, there's been an imbalance, if you will, of the demand for consumers who want more and better digital services versus the talent pool of people who are available to create them and maintain them, which are developers, operations professionals, software reliability engineers. And when you have that imbalance, it creates this huge demand for solutions that improve productivity, increase the velocity of software. And there's been a whole ecosystem that has emerged in and around that. Arguably, cloud infrastructure with, AWS and the way that it launched, that was originally a developer toolkit, a developer set of building blocks that was there. So that was a response to this almost huge need of developers to have fractional access to compute and storage when previously they didn't have access to that. They couldn't afford it, couldn't work the management channels for that. And so as this imbalance has increased over the years, the ecosystem has grown pretty tremendously. And I maintained that database, used it to help source some investing deals along the way. And starting a couple of years ago, we decided to publish it and all the trends related to that. And now the database is available online. We have over 1,000 companies that we are tracking inside of that database across 17 different categories that we've named and organized ourselves. And that total market tracks towards about $50 billion in annualized recurring revenue from these products that developers either build, they influence the purchase of, or they directly consume.
And so when you say developer-led landscape, are you coming from a perspective that is about the actual developer experience, or are you coming from a perspective that's different to that, to do with like the investment portfolio that you're describing?
So when I talk about developer-led landscape, it's specifically products that either developers need to consume in order to construct the software,
Gotcha.
Products that developers need to consume in order to run the software, like some sort of application server. It's also products that development teams need to organize the team through the supply chain of the production of the software. And it's also, if you will, organizational governance and lifecycle solutions that help organizations manage teams of people to be more efficient, collaborate better, organize their thoughts. And so any of those products fit into that landscape because they really drive the day-to-day behavior of developers, or they are directly consumed by developers themselves.
I see. So it's if I'm a developer, it's the toolkit that I'm using and the perspective I have as a result of needing certain tools in my toolbox.
Yeah, as an individual or part of a team, or even maybe organizationally at large as well.
I see. So the distinction from that with something like DevOps, where DevOps being the broader methodology that you might be kind of employing, the developer-led landscape is more the sort of toolkit that you're using to sort of to develop within whatever environment you're developing in.
Yeah, there is a significant overlap with the most common term, which is DevOps. But I think in DevOps, it tends to focus heavily on the intersection between where operations teams and development teams intersect. And when we think about the developer-led landscape, DevOps doesn't include all the stuff that developers need during design, coding, testing. There's a lot of earlier things that happen in the requirements and formulation stage. And there's also a lot of governance and lifecycle solutions such as chat systems, legacy enterprise information management and tracking, agile management, engineering efficiency. There's all sorts of other broader concepts that are generally not considered part of DevOps that we wanted to be inclusive of. Because without these solutions, you really can't manage your development teams or improve their productivity.
I see. And I think you've identified a series of trends that when you look at the world of development, the first trend being the emergence of a service catalog.
Yeah. So what's interesting is, I think we're about to see an evolution of developer technologies that have followed the same sort of evolution that data technologies have gotten. And so over the past decade, the complexity and modality of data systems has really exploded. We have graph databases, we have relational databases, we have NoSQL databases, we have time series databases, data warehouses, data lakes, database management systems, just raw object storage. And so that diversity has really led to the need for an explosion in data management and data governance. And the way that you predominantly do this is that you've got some sort of data catalog, which is a repository of the metadata about the data. And it describes the people who are accessing the data, all the different data systems, and provides a way for you to get freshness of the data lineage, and to track it all. Well, guess what? On the application development side, we're seeing equal levels of complexity. There's well over 1,000 programming languages that are used to produce software systems today. The architectures for applications have gotten tremendously harder because of microservices, the diversity of APIs, the complexity of runtime systems like Kubernetes or platforms as a service. And so with that complexity, it's becoming harder and harder for individuals to reason about changes to a system, whether you're a developer or an operations professional. And so service catalogs are going to be the equivalent for the application tier that the data catalog was for the data tier. It'll be metadata that describes these systems, metadata that describes the teams who interact with each of the different services and their role in that. And you need that metadata in this service catalog as a way to make competent, effective change in these systems that are increasingly becoming too complex for humans to reason about.
Right. And you go on, I think, in trends 2 and 3 to talk about, the convergence of continuous delivery and the development life cycle itself. So how do you see those things coming together with the service catalog?
Yeah, well, there's a basic premise in software that if every company now can only differentiate themselves through software on the planet, right? All hundreds of thousands of companies, then your velocity as a software company, whether you're manufacturing or healthcare or whatever that is going to fundamentally define your competitive posture relative to your rivals out on the marketplace.
And of course, that's the point that a lot of organizations try to get at when they talk about things like cloud transformation and they talk about things like increased agility. What that actually boils down to is being able to create environments within which your developers can move faster and get to market faster with new product.
Yeah, and I wouldn't quite use the environment, but I would describe it as creating a working I guess environment. Yeah, we'll go with that. A system, if you will, of culture and technology and platforms and the right mix of people that you've got so that you can just produce an output of software a little bit faster than your rival can produce the same output of software. And if you can do that without having heavy attrition of the team, over the long run, you've got an advantage over your rival in that sense. And so I think savvy organizations that take a step back and look at, okay, well, how do we do that? Well, the first anchor of that is we have to eliminate attrition. We have to anchor around, how do we retain the very best talent for the longest periods of time? But then the second is that how do we increase our cycle time? And if you increase your cycle time, there's a couple of formulas. You want to make more changes more frequently. You want to make more changes per developer. And the only way to do that is to allow for these changes to be automated, not just through design, but all the way as they get pushed out into production. And so historical systems that had a lot of manual controls in them are getting removed for systems that have total automation, where the robots are taking over. And that's CI, that's continuous delivery, that's feature flagging, that's experimentation. And you can get to a point now where a developer can make a micro change, and the system will take care of making decisions about how far it makes its way through test and QA and production, and then accessed by users or rolled back. And so you really start to remove humans from that and turn it into a mathematical operation. And as a result of that, all these big developer platforms, CI/CD, feature flagging, experimentation, they're going to have to consolidate into one giant mathematical system.
Right. Vastly complicated. Do you see that being something that the industry responds to in terms of integrating those things, or do you see that as something that will need to happen, in each organization as they're deploying their developer environments?
Well, I think a lot of organizations that are practitioners of software are still on the earliest stages of their continuous delivery, feature flagging, and experimentation. Is very, very low penetration. But the software vendors themselves are already recognizing this consolidation, and you're starting to see it emerge with the big platform vendors. GitLab and GitHub are definitely adding these capabilities one step at a time. And then the big siloed vendors, LaunchDarkly was feature flags. Cloudbusting was for CI. They're both, very aggressively acquiring and building out capabilities to broaden that stack as well. And that's a reflection of this other kind of the mega theory that I have about the whole developer landscape, which is that every 15 years for the past 50 years, it's gone through a consolidation followed by a fragmentation cycle. And I cannot figure out why it's 15 years, right. but you can trace this back, and it's a pretty reliable. And we're just now entering we're in year 2 of the next consolidation cycle. The last fragmentation cycle kicked off in 2005 with the introduction of Git, and I can talk about why Git caused that. But there's been a huge fragmentation, and it's introduced a lot of the complexity. And the complexity in the tool chain is now too overwhelming for most organizations. And so we'll see a consolidation wave along a couple of major vendors. And I think that GitLab's market share, not market share, but their market cap in their recent IPO is a reflection of how much the market sees that same consolidation happening.
Yeah, that's fascinating observation. And we'll look forward to tracking that over the course of the next couple of years. And maybe that takes us on to Trend 4, where you're talking about products that improve the developer experience are growing dramatically faster. Is that what you're getting at there, or is there something else underneath that?
No, the consolidation phase in many ways is a detriment to what true experience, believe it or not. I can talk about that. Consolidation is really a way of avoiding having to hook up different systems together. And so since you don't have to hook them up, there's obviously some productivity benefits that come from that. But no, when I talk about developer experience, it's really experience is one of only 3 things that developer landscape companies can truly differentiate on. Like if you're a new startup there, another one is security, and the third one is cycle time. And a lot of these companies don't recognize that when they get out there. They usually try to come out with some sort of other value prop. But experience in this case is about taking some fundamental part of the software construction process and incorporating it in near subliminal ways into the developer's existing workflow. And when you can incorporate raw new functionality without asking the developer to change how they've been working, and when that developer is in that edit, test, cycle flow that they get, you find that developers will swarm and adopt it very quickly. And as a result of that, it becomes kind of a lock-in mechanism. And so the vendors that have really innovated on that front, there's been SNCC who's done it for static analysis and security testing.
Right. We know SNCC.
They put it right into the pull request workflow so that developers didn't even have to think about it. It's also happened with Microsoft's VS Code and the way that they do plugins for the editor on that. And there's also been some companies in the platform as a service realm who have incorporated deployment as part of the Git commit workflow. And these seem like really minor advancements, but that being part of that developer's flow causes you to get potentially hundreds of thousands, if not millions of developers to adopt you very rapidly. And those companies that get that are scaling faster than companies that don't.
Right. Good stuff. And let's talk finally then about Trend 5, which actually sounds pretty fascinating, where you talk about a shift from code writing to composition, which is driving a reimagination of DevOps underpinning new platforms. And I'm particularly interested to start this conversation with a distinction between code writing and composition for those that don't.
Yeah, well, if you go back to about 20 years ago, 85% of all code was written from scratch as part of a software system, and 15% was reused from some library. And those libraries were generally libraries that had been developed by the same company because you had access to them. Now, roll the clock forward 20 years, you've got the emergence of open source, so that there are, understood legal licenses on how software can be shared. You've got most of the major programming languages have build systems and artifact repositories so that units of reusable business logic can be shared and published in an open way. And you've got, not just because of open source, but the nature of GitHub and GitLab really have provided a way of outsiders providing collaboration on projects that they haven't previously had involvement with. And the combination of all those things, along with the emergence of the API economy, with well over 1 million public APIs that offer reusability, and the emergence of low-code systems, which are really, graphical ways of increasing utilization of third-party services. You put all those things together, and now most systems are built by taking 85% of reusable components off the shelf, and then 15% of writing the code that makes all those components work together on that front. And so if most of the developer's time is in researching the components or supporting the components or diagnosing the components as opposed to writing the code itself, the dynamics of the ecosystem have swung a little bit away from developers who need to write new code and into developers who have to manage ecosystems of components, which are using their own components, which are using their own component. That's called transitive nature of that. And the complexity has become very different as a result, because even though your system may only, source 10 components, it might actually be sourcing millions from the transitive nature of everything that's going on there.
In terms of then applying that to DevOps, would that then mean that DevOps becomes less a code writing exercise and more of like an aggregation exercise of existing code? And is that the reimagination that you're seeing, or is it something different?
It is part of the reimagination. I mean, the security implications are huge. The next 5 years are going to be defined by how do you secure the supply chain, and it's the issues aren't in the code that you write. It's the code that you're sourcing, and do you trust the source of that code, and what about their ability to source code themselves, and how far does that go, and how do you sign that and verify that? And that security dimension is just one flavor of this. You have to worry about a performance dimension. You have to worry about an operations and maintenance dimension of it all. And so things were a little bit different when you had a code base where 85% of it was stuff that your team wrote, and you could understand the source and the genesis of it over time.
It feels also a little bit like what the hyperscalers are doing in terms of if we pull this into a cloud conversation, it feels like these sort of cloud native applications and the cloud native services that the hyperscalers or the CSPs are creating. it's a similar move, right? It's okay. I no longer have to write the code to do task A. I can just go and pull a cloud native service that one of the CSPs has got there offering to me.
It is exactly that. I mean, because the building blocks are understood. We didn't understand the building blocks 20 years ago, but now we understand. We really need to do a certain type of memory responsive, hash map or whatever it might be. Or hey, I really need a certain type of shopping cart. Or hey, what I really want to do is I want to convert currency. And so the abstractions have gotten higher and higher. Where this gets really interesting, and this is where I'll bend your noodle a little bit, is we're at 15% writing, 85% composition. When the world gets closer to 97% composition and 3% writing, that's probably the threshold where humans don't need to really be involved in the construction of the software anymore. And that we can delegate that off to the machines to create the software that we need, because then you get into modes of, hey, I just need to describe the intent and the capabilities. And the machines, since all these components are very well structured, they have very well defined interfaces, you can apply semantic meaning to that. We can teach the machines on how to go and composite these things and come out with the right solution in the end.
That's pretty extraordinary. And to get a sense of how far away are we from that, how long has it taken to get to the current ratio?
Well, it took us 20 years to get to this ratio, but I think it'll probably be another 20 years to get to the last one. I was speculating a couple of years ago it was only 10 to 15 years away, but now it feels maybe 20.
Yeah.
If this happens, and I'm pretty sure it will, it'll probably come out of the testing space for two reasons. The testing space, one, is still largely human driven, believe it or not. I mean, it's tens of billions of dollars spent of humans who are manually testing software. And so that's just ripe for innovation that, somebody needs to, take that away. But the second thing is that testing is harder than writing code, because you write one unit of code, but there's probably squared permutations of things that need to be tested. So if machines can figure out how to dynamically and automatically test a piece of code without the human telling it what it is, if we can figure that out, then teaching machines how to write the code is a lot easier than testing it.
That's how Skynet started.
The scariest thing I ever heard was that there's something like 100,000 robots that Amazon has purchased that they don't know, they can't locate.
Oh, no.
Like somehow.
They're physical robots.
Physical robots that do robotic things in their warehouses and they can't find it. And my whole theory is that they're at the bottom of the ocean planning.
Yeah,
exactly.
They might be out back having a cheeky smoke.
And my big takeaway from this is that even Dave could become a coder soon.
I wouldn't go that far, Jazz.
No, probably not.
I think we need to be up at the sort of 94, 95%. And then, with a nice drag and drop interface.
Hey, in this day and age, you can get a 50% pay raise by becoming one.
Oh, mate, honestly, the salary inflation is just insane, isn't it?
I know.
It's pretty ridiculous, yeah. And we'll see if this is sustainable or not. As systems become less custom and more predictable, and the machines can bake in that knowledge, I think that this idea of the 100x engineer, this guy who can somehow just magically produce things in ways that others, I think that probably starts to diminish a little bit. And engineers are still talent, don't get me wrong, but they're not this kind of rare eagle, if you will.
In the shorter term, though, where we've got a very tangible talent crisis, what do you think in the next couple of years the industry has to do to lean into that and seek to resolve some of that problem?
Well, one, I think the industry has to double and triple down on its diversity and inclusion messaging as an industry, because we're not tapping into every interested party, whether it's female or minority, that could really be great in this ecosystem. So they've got to really commit to that as one. The second is, I think we definitely need to see more forms of automation. We're barely scratching the surface on what automation in and around the software construction process looks like. The third is that I generally think that platforms and architecture are way too complicated. And so the bar for new entrants is way too high. It really is a 4 to 10 year journeyman learning cycle to appreciate these technologies. And there's just really no need for that. And I frankly, if it wasn't that difficult, I don't think we would have seen the emergence of the low code segment. The low code segment is now 130 companies competing, probably a few $1 billion in revenue. And these low code systems, they're decent, but they're not great. And really what it's done is I think it's unlocked this pent up demand to create these kind of what I call 24/7 apps, which are apps that if they crash from time to time, no one really cares. They provide some basic functionality for a small group of people. And a business guy goes in there and maintains it. It's like my Excel spreadsheet. It works half the time. It doesn't work half the time. I go in there and I fix it, and everybody's fine with that on that. And so I don't think if we hadn't made the software stack too complex, I don't think we would have seen the emergence of these other systems there.
Thanks, Tyler. That was fascinating and a little bit frightening in itself.
Like all good conversations.
Yes, exactly. Brilliant. Okay, that takes us on to our 10-second recommendations, where we like to just recommend something to our listeners. Not normally work-related, but feel free to do so. Dave, let's start with you today. What have you got for us?
So mine is an Apple TV Plus show called Watch the Sound. And it is a 6-part documentary, and it's Mark Ronson, who I'm a bit patchy on Mark Ronson from a sort of music and reputation point of view, but Watch the Sound really reframed him for me, and it's like a really good nerdy look at different things that he thinks have influenced the sound of modern pop music. So there's an episode on the sampler, there's an episode on the drum machine, there's an episode on effects pedals and stuff like that. And for each episode, he gets in guests that are sort of known for, kind of innovating in that particular space. So he has Moroder on in the synth episode, that kind of thing. And it's really fascinating. Like really deep dives into it, very watchable and, amazing for somebody who listens to a lot of music. Excellent.
Cool. Tyler, what do you have for us?
My wife and I just visited Olympic National Park up in Washington. And it was pretty remarkable to us because we just recently relocated to Oregon. And this is a pretty accessible national park. It's right there on the ocean and the bay. There's an airport that is literally a mile away from the park's entrance that you can fly into. And, beyond it being, probably one of the most beautiful places we've ever been, it's also got rainforests in and around the mountain, depending upon where you go, where it's kind of constant rain all the time.
Wow.
Sounds great.
So the scenery in the US is just immense, isn't it? I mean, I'm in Vegas at the moment, and you look out the window, and it's the mountains and the beautiful sunrises. There's the Zion National Park, the Grand Canyon, and then you talk about these other parts that no idea, but you're saying the most beautiful place that you've ever been to in the world. It's like, wow,
amazing.
It's pretty remarkable because my wife and I we have a little plane. I've got my pilot's license, and it was only a 45-minute flight. We flew into this little airport, and 10 minutes later, we were in the park hiking.
Fantastic.
You can't do that very many places.
Dave, you normally take your plane, don't you, when you go to parks?
Plane or helicopter. It just depends on, kind of how much space you got to land it.
Yeah, no, that's true.
Yes, what's yours?
Bill Bryson. So I'd never read any of his books.
Oh, I love Bill Bryson.
Yeah, it's like, where's he been all my life? I was on the flight, and the choice of movies on the plane was just diabolical. I guess there haven't been many movies out, right? And so it was all really scraping the bottom of the barrel.
The sort of stuff you flick past on Netflix and go, no.
When we were on the ground, I was looking up the IMDb scores, and they were like, 3.8. I'm like, how can you? So literally nothing to watch. So I downloaded Bill Bryson, The Short History of Nearly Everything. And it basically describes the start of the universe through to how humans have evolved. And it is fantastic. It's such a good read. I'm going to now sort of work my way through some of his books.
If you read, my favourite of his is Neither Here Nor There, which is, most of his books are travelogues. rather than that sort of thing. And he's going around England or going around Europe or the US. And neither here nor there is his European one. And he starts out in Hammerfest, like right at the very northern tip of continental Europe to see the Northern Lights, and has to spend like 2 weeks in sort of a tiny village with like only one tiny bar. And he and he decides to commit to wait it out so he gets to see the Northern Lights. And then it goes on from there across Europe. It's brilliant, literally hilarious.
I will give it a read, definitely. Brilliant. Tyler, thank you ever so much for coming on the show. Really, really enjoyed that conversation. It has frightened me a little bit. I said we're in the 15-year cycle. We're into year 2. So it's about 13 years before really the robots do start taking over. So I'm going to enjoy the next 13 years, and I think we're done. Appreciate you coming on. Thank you.
Thank you for having me. It's been fun to be here.
Dave, great to see you again. Enjoy picking up the kids.
Thanks, mate.
We are on Twitter at CloudbustingPod. Please do feel free to tweet us. We're also all on LinkedIn. Do feel free to connect to us. And for those of you that are listening to this before November the 29th, and if you happen to be in Vegas on November the 29th, please do come and see us. We're doing a live show at the Venetian Hotel. Come and see us. And we're also on the booth at reInvent. We are on booth 369. Come along and say hi. And we'll talk to you next week. Goodbye.